let's look at problem 11 as our last problem here from the review sheet. It says we are to identify the constraints, non-negative conditions, and objective function for this situation. We didn't have to solve it as we just got through doing in problems 9 and 10. We just had to be able to write those items. So it says a city has $600,000 to purchase cars. That sounds like a constraint in terms of money, doesn't it? If it only has that much money to purchase cars, wouldn't that probably be the maximum figure we can spend? We can't go into debt beyond that. So the cost of buying the cars is going to have to stay less than $600,000. A city has $600,000 to purchase cars. Two models, the B250 and the X100, I wonder who makes those, are under consideration, costing $15,000 and $25,000 respectively. Looks like those figures are going to enter into my constraint here for cost, aren't they? The estimated annual maintenance on the B25 is $600. Okay? So $600 per year for maintenance. And on the X100, $800. So it costs $800 per year maintenance on those cars, the X100s. The city will allocate $40,000 for the total annual maintenance. Oh, that looks like another constraint. The maintenance has to stay less than or equal to $40,000. Doesn't that make sense that that would be another constraint? The B250 gives 30 miles per gallon. Okay. So the B250, I'll write that over here, 30 mpg. And the X100, 22 miles per gallon. Because of certain transportation needs, the city must buy at least two X100s. Oh, okay, so we have to buy at least two of this car. We can buy more, but we have to buy at least two of them. The city wants to maximize the miles per gallon factor. For X B250s and Y X100s, the miles per gallon factor would be figured as 30X plus 22Y. How many of each model should the city buy? So if we're going to let X represent the number of B250s we should buy, and Y represent the number of X100s we should buy, then yes, that 30 times X would be giving us the total miles per gallon that we would get from those B250s, plus 22Y is the total miles per gallon we're going to get out of the X100s. And in effect, then, if that's what we want to maximize, isn't that really our objective function in this particular situation? So let's see if we can put all this information together into some constraints. Well, again, a constraint, let's start with that constraint of maintenance. We can only spend $40,000, that's how much has been allocated, for maintenance for the whole year. And for the B250s, it costs $600 per year for each car. And the X100s, the annual maintenance is $800 per year. So wouldn't 600X represent the total amount of money we're spending for maintenance on the X B250s we buy, plus 800Y? Wouldn't that represent the total dollars we are spending per year on maintenance for the Y X100s we're going to buy? And then let's look at cost, a constraint for cost. It costs us $15,000 per car for the B250s. How many B250s are we going to buy? We're representing that by X. So wouldn't 15,000X represent the total dollars tied up in buying B250s? And then 20,000Y would represent the total dollars tied up in buying Y X100s. And of course, we're going to buy the cars, so you can't buy negative cars. So we would have those two non-negative conditions. The number of B250s we're going to buy, it has to be at least greater than or equal to 0. And the number of X100s we're going to buy has to be greater than or equal to 0. Or actually, it has to be what? At least 2, doesn't it? We were told because of certain transportation needs, we have to buy at least 2 X100s. So what inequality would express that the Y value has to be at least 2? It could be greater, but it has to be at least 2. Wouldn't that be this inequality? Wouldn't that be the inequality that would be telling us we're buying at least 2 of the X100s? And we've completed the task. We have our constraints, which this is actually another constraint. We have to buy at least 2 of the X100s. We have our non-negative conditions, and the value we want to maximize is the miles per gallon factor. And the miles per gallon factor is found by taking the miles per gallon for one car times the number of cars we're going to buy, adding that figure together for the 2 types of cars we're purchasing.